Hello everyone, this is James Shore with another how-to video. I'm recording this on September 8th, 2015. In the last episode, we just finished up a chapter on cross-browser testing, and I'm just thrilled with how it turned out. As a quick reminder, we now have the ability to run one command and have our code tested on all of these browsers, i.e. 9, 11, Safari, Firefox, Chrome, Android, and iOS. In just a matter of moments, all of our tests are running on all of those browsers. Now we are going to start a new chapter looking at modularity. The problem with the code that we have right now is it's all in one file, and in a real program, in a serious program, you want to be able to split up your code into multiple files, one file for each important concept in your program. That's because the biggest, most challenging problem in professional software development isn't actually writing the code, it's maintaining the code, it's understanding code that other people have written. When you have tens of thousands or hundreds of thousands or even millions of lines of code, finding it is a real issue. And putting all those hundreds of thousands of lines of code into one file, well, that would just be a mess. So one of the most basic things we can do to organize our code is to split it up into logical units, units that are related and make sense. JavaScript does not make this easy because by default, JavaScript, at least as of today, does not have a mechanism for multiple files. Now, at the time of this recording, again, this is September 2015, there is the ECMAScripts 2015 standard, which does add the ability to use modules with JavaScript. Modules are really just multiple files. Each file is called a module. At this time, though, modules are not widely supported, so JavaScript does not have support for multiple files, again, at this time. This is a problem because this is one of the most fundamental capabilities of programming is to split your program into multiple files. So what we're going to do in this chapter is look at the different ways you can split your program into multiple files. And we're going to do that by taking this little test program here and splitting it into a test file and a production file, the code that actually is going to run for the user, not the code that runs for tests. Now, there are three different ways of providing modularity to JavaScript, and they all basically do the same thing. They use a third-party program to convert your modules into a single file that you can actually load into your browser. The first one is called CommonJS, and this is what you've seen in our Jake file. When we say require here, this is a CommonJS format. The second is AMD, Asynchronous Module Definition, and the third is the forthcoming ECMAScript 2015. Eventually, browsers will support that natively, but right now, you use a third-party tool to, again, combine all your files into one to load into the browser. Now, if you want more information about CommonJS and AMD, check out this Lessons Learned video right here. I am going to use CommonJS in this series because it's used by Node and it's sort of the de facto standard at the moment. In another year or two, when browsers support ECMAScript 2015, that will be the actual standard, but at the time of this recording, it's not in wide use, and I think CommonJS is a better choice. It's nice and flexible. As I said, it's what's supported by Node, and I like consistency between my Node code and my browser code. So in order to have our test use this CommonJS code, we just need to use require statements like this, and then use some third-party tools to make that code understandable in the browser. Let's start out by taking our addition script right here, which is working. We can run the test and see that it's working. Let's take this and split it up into two files. Now, if you'll recall, what we have here is just a simple little function to add two numbers, and we're only using this for the sake of example. It's a kind of a ridiculous example, but it's nice and simple, and that's why I like it. Here's our tests that say that we can add positive numbers and that we're using floating point math, and here's our production code. These really should be in separate files, so let's go ahead and split them up. There are multiple ways to organize your code. Your team is going to have their way of doing it, so just follow their way. My choice, my preference is to put everything in a source directory and start tests with an underscore and production code with not, without an underscore. A lot of people prefer an approach where they have their test code and their production code in two different directories, that is also perfectly valid, but I like keeping my code close together because we tend to open both files at the same time. So I'm going to go ahead and do that instead. So here we have our test code, which I'm going to rename to underscore, well, whatever the name of our production code is going to be. Let's call it addition test.js. And I'm going to copy it and make an addition.js as well. And in addition test, I'm going to erase the production code. There, it's gone. And in addition, I'm going to erase the test code. So now we have addition test and addition. For addition test to use the addition module, what we need to do is require it. So we'll say var addition equals require addition.js. This is just like you've seen in our Jake file. Whenever we want to use another module like, say, JS hint or karma, we require it, and then we use it by saying karma and then dot and the name of the function we want to call. So here we're going to say addition equals require addition.js, and here where we're going to call the add function, we'll say addition.add and addition.add. Now, there's something special going on here I want you to particularly notice, and that's that we started our require addition.js with /. If you don't start with a dot, then require loads npm modules. It'll look in the node modules directory and load any modules that you've installed through npm. By saying require ./addition.js, we're saying look for this module relative to our current module. So look in the current directory, that's the dot, followed by the addition.js file. If we wanted to look in a subdirectory, we'd say ./subdirectory/module name. And if we wanted to look in a parent directory, we'd say ... that means parent directory, ... and then whatever we wanted. The important thing to remember here is that if you want to require a module that's not an npm module, you need to start with a // or ... Now, over in our module, which we've just created, we have to do something special in order to make this function accessible to everybody else. Now, this is the first time we've done this, so let me run through it. When we make a function accessible to other people, that's called exporting the module. And the way we do that is by using a global variable, or really a module local variable, that's provided to our file by the CommonJS spec. Now, again, this is not standard JavaScript. This is something that's going to be added for us by the CommonJS tools we use. What we do is we say exports.add equals add. This is going to say, what happens is this exports variable is what is exported, is what is returned by this require statement. So anything we add to the exports variable, in this case we're adding the .add variable, and assigning the add function to it, anything we add to the exports variable is also available to anybody who requires this module. So addition, this return value, is going to be the same as exports, this exports value. And add is available on addition. We can say addition.add because we've added it to exports by saying exports.add equals something. We could put whatever we want here. We could put 1, 2, 3 if we wanted, but down here when we said addition.add, then it would no longer work because 1, 2, 3 isn't a function. So we're just going to say exports.add equals our add function. That's what we want to export. We could also do this directly by saying exports.add equals function add. And that's a slightly more compact way of writing the exact same thing. And I'm going to go ahead and do that. So again, whenever you create a module in CommonJS format, the way you export functions from that module is by saying exports dot and the name of the thing you want to export. And then anything you want to assign to that, you can. And in the CommonJS format, every file is a module. You can load any file you want using this require statement. So we've done that. It should work, right? Well, no, because this is going to get loaded into browsers using Karma, and browsers don't understand require. If you look at here, we're getting an error from every single browser saying require is not defined. So what we need to do now is we need to tell the browsers what require means. We need to have a tool for using CommonJS in the browser. Now, there are two ways of doing this. One is to run a third-party tool and then have Karma ship the results of that tool into the browsers, and that's probably the most straightforward way. But a somewhat better way is to actually install a plugin into Karma that understands CommonJS. And the reason for doing this is that it's a little bit simpler than having your build script do the building for you beforehand. And if you use the right third-party plugin, you can get better error messages and better stack traces as well. When you get a failure, this list of files and line numbers, that's called a stack trace. And a CommonJS tool is going to combine all these files into one file, which will break your stack trace. But a good CommonJS plugin for Karma won't. Let's go ahead and check in what we have so far. There's a few different ways of getting CommonJS to work with Karma. One is Karma CommonJS, which is actually a tool we created over on the live channel. You can find the details of how we created it at this episode link right here. I do need to warn you though that that is pretty advanced stuff, and it gets into the gory details, deep into the sausage factory of how CommonJS works. So only check it out if you really want to know those details. Karma CommonJS works by translating each file as it's loaded into Karma, preserving the individual files, which is nice because it loads very fast and it gives you good stack traces. Another tool is called Karma Browserify, which runs a third-party tool called Browserify that converts a CommonJS set of files into one single file and then passes that off to Karma. It's a little bit slower, but not too bad, and it doesn't have as nice stack traces. Either one of these is valid. The one I know best, though, is Karma CommonJS, so that's the one I'm going to show you here. The way you set up any plugin for Karma is first we need to install it. So let's go ahead and say npm install Karma CommonJS. We'll ignore scripts as always and save dev. Then we'll go ahead and check that in. And then do an npm rebuild to check for binaries. But as usual, there aren't any. Now what we need to do is open our Karma configuration file, which is right here, and add the CommonJS plugin. There's two parts to this. First, we add CommonJS here under frameworks. And second, because Karma CommonJS works by modifying the files as Karma loads them before they're sent to the browser, we need to tell Karma that which files are processed by Karma CommonJS. In this case, it's going to be everything in the source directory and any directory under it that ends in .js. And we're going to tell it that we want those files to be processed by the CommonJS plugin. Just like that. Once we've done that, we have to restart Karma so it will reload its config file. So I'm going to kill it. That kills all of our browsers, disconnects all of our browsers. Then I will restart it by running jake karma, reload one of them to see if it worked, and run our test again. I'm going to say loose equal true because we're only loading one browser. I don't want the test to fail just because I don't have all the browsers loaded. So hopefully this will work. And look at that, it did. So that's Karma CommonJS. That gives us the ability to require files, require production code from a test file. Now, this does not actually give us the ability to use modules in production. If we were to load this edition test.js directly into the browser, it wouldn't work because this is only going to work with Karma. So next time what we're going to look at is how to get modules working in production as well as in tests. Your exercise this time is to split up your edition test or whatever test you have into multiple modules, and then go ahead and install Karma CommonJS and get it working with Karma so that your tests pass even with multiple modules. If you want a bit of an extra challenge, go ahead and try getting Karma Browserify working as well. I've heard good things about it, although I haven't used it myself. Take a look at it and see what you think. That is it for this time. Thanks for watching, and I will catch you next time.